Hopefully that helps. Yeah, I actually uploaded it several times, deleted it several times because of it. I wasn't too sure about the copywriting. Well, we'll see.
Well, they let you post them last
Huh?
semester. They let you post
Well, so last semester what happened was the school had a contract with a company that upload this for us, and they basically limit, they can remove what's in there when it's, yeah. So I don't know. We'll see. At least we're trying to help the students. What did I say?
No, sorry.
Alrighty, so let's continue. We're going to finish chapter 20 today, and then start on chapter 21. Okay. And even though we have the lecture videos on, please come to lecture. Okay? Because last semester I almost regretted uploading that because like midway through the lecture, students were not coming to the lecture because they know they will watch the video. I know. But please come to lecture, you know.
We're here.
Okay, there you go. All right. So preparation of nitriles. How do you prepare nitriles? Okay. So the reaction, most of the reaction here are reactions that we've seen. So let's just go through them. The first reaction we're going to consider is SN2 reaction of cyanide with primary or some secondary alkyl halide. So your cyanide ion is a nucleophilic ion. So this can act as a nucleophile, attacking your electrophilic carbon of the alkyl halide, kicking out the halogen. So now you have Cn in place of the halogen. So for this secondary carbon center, that's your electrophilic carbon. And the halogen will be kicked out, so you have now, excuse me, since this is an SN2 reaction, you should remember that it occurs with inversion of stereochemistry, correct? So if you have a chiral center, as in this example here, and the chirality is shown, when you draw your product, it's going to occur with inversion of stereochemistry. Okay, so please note that. So that's the first reaction of, that's the first formation of nitriles. So you can form nitriles from alkyl halide, conversion of alkyl halide to nitriles. Another way to make nitriles is to dehydrate primary amides. Some people say amide, some people say amides. So formation of amide is something we'll be talking about later on, because it's one of the derivatives of the carboxylic acid functional groups. But at least you should know that if you have a nitrogen connected to your carbonyl, okay, so this group is called the amide group. So you can dehydrate primary amide. What do we mean by primary amide? It has two hydrogens connected on. So you can dehydrate such to give you nitrile. So what is the mechanism for that dehydration? You'll be using thionyl chloride to perform the dehydration with heat. Okay, thionyl chloride. So you know that thionyl chloride is a chlorinating reagent, right? So if you treat it with an alcohol, you convert that alcohol functional group to halogens, right, to chlorides. But if you treat it with amide, they act as a dehydrating reagent. And how does that work? So the first step is the nucleophilic attack of the carbonyl oxygen on the sulfur. So basically, because this is your electrophilic site, I don't like showing that carbon, but okay, I'll just put it this way. Bless you. Okay. So this is going to reform the carbonyl type structure, so sulfur oxygen double bond. This chlorine will be kicked out. And I'm going to use it to pick up this proton. Okay. And the electrons here will be pushed to make a double bond between the carbonyl carbon and the nitrogen. This double bond will break and the electron will go onto the oxygen. So you'll have a double bond here. This nitrogen has one hydrogen left. This is now oxygen bonded to the sulfur which has a double bond with oxygen, and you have one chlorine left. So this chlorine has picked up this hydrogen to form the first mole of the HCl. Okay, so you can see that in the byproduct you have 2 moles of HCl there. So that's how you get the first mole of the HCl. Okay. Bless you. Now, the lone pair of electrons you have on this nitrogen, we used to make another pi bond with the carbonyl carbon there, or the previous carbonyl carbon. This whole group here now becomes a very good leaving group. So the oxygen carbon bond will break to form a carbon double bond with the sulfur. Why is that possible? Because you have a leaving group in this chlorine. Okay. So, but the electron is going to move around the carbonyl, is going to reform back before the chlorine will be kicked out. Okay. So here you have this. Now you have this carbon triply bonded to the nitrogen. That nitrogen still has the hydrogen there, so it's positively charged. Now you have sulfur dioxide, okay, and the chlorine that was there now from the ion floating around to stabilize the positive charge that you have in the ammonium salt there. And this can pick up the hydrogen, you regenerate the lone pair of electrons on the nitrogen. That's how you obtain your nitrile with the second equivalence of the HCl plus SO2. Okay.
Can the chlorine pick up the hydrogen at the step where?
Yeah, so we could basically I could draw this to come and pick it up. We can write the mechanism in like one step, but it may look very confusing. So that's why we're showing this step. Okay, so basically you could have done, let me see, paper here that I can write on. I do. Awesome. So what Stephanie was asking is, over here we could have written this in this form. Oh, that was too close to the top. Why did I do that? That's okay. Okay, so this could have been written this way. Form the triple bond. This will break to form a double bond. This double bond here will break. It's going to reform back this chlorine. But if you do that, then you have to move this bond back over here. Okay? So in one step you can do everything. Or better still, if you want to, if you don't want it to look that messy, you could go this way, because you know that the electrons you're moving are the electrons in the bond, right? When you're breaking the bond. So another way to look at this is, okay, since you know that this bond will be breaking, if you move this electron here, and you break this bond to reform it back, you can now move these electrons to pick up the hydrogen, and then you draw your arrow from the nitrogen-hydrogen bond over here. Okay? So many ways you can do it. Okay? But it's always good to go stepwise so that you can understand what is happening in each step. Because I don't know how Al is going to be asking you questions. Maybe he's going to say, show the intermediates that you form when you break this bond, right? So you have to understand every concept there. Okay? All right. So that's how you dehydrate amides to get nitriles. Okay. So let's just give some examples. Let's say you have, okay, so let's call this examples. Okay. Let's say you have acetamide and you treat it with tannate chloride. Benzene that you have there is a solvent, so it has to be done in a certain solvent, and then heat. So sometimes they will just put this sign as heat. Okay. That will give you 1, 2, 3, and okay. If you have nitrile. Okay. This is the same thing as showing the carbon if you want to. Okay. All right. So now let's look at the reaction of nitriles. What are the reactions they undergo? So basically, you can put any R groups here and get as many. All right. So let's look at the reaction of nitriles. Reaction of nitriles. The first reaction that we're going to consider is hydrolysis. You can hydrolyze nitriles. So the hydrolysis can be done under basic and under acidic condition. Okay, so you can use either base or an acid. What you obtain in the process of the hydrolysis, the final product is going to be your carboxylic acid. Although you have an intermediate amide that can further be hydrolyzed. Okay. So, what's the mechanism? Let's do the mechanism for acid catalyzed. Okay. So here your nitrogen can pick up the proton. So like that, the proton on, positively charged. And at this point, your water molecule is going to act as a nucleophile, attacking that carbon. You break one of the triple bonds, one of the pi bonds there. So now you're going to Okay. So there's going to be a proton transfer so now your proton is on the nitrogen. Okay. So this oxygen will form a carbonyl. This electron will be pushed onto the nitrogen. This is my NH2. It's positively charged. And another water molecule will act as a base at this point, picking up this proton and you form your amide to regenerate your acid, right?
You can't see.
Oops. Okay. So that's your acid. So let's see. So at this point, so this is basically an equilibrium reaction there. It's going to pick up that proton, become protonated again. Okay, which activates the carbonyl carbon. So water can act as a nucleophile, like in that. Then you break this bond. Okay. I'm gonna bring this down here. NH and NH2. Okay. Okay. So at this point, there's going to be another proton transfer onto the nitrogen. So now this forms NH3 plus. Okay. The formation of your carbonyl carbon or your carbonyl functional group will kick out the ammonia. Okay. So that'll be NH3, which is a gas that's given off. Water can act as a base now to pick up this proton. I should have drawn it to this side, but that's okay. Pick up this proton, and then you free your acid, you get your carboxylic acid plus NH3, which is given off, plus H3O plus. So that's how you get your carboxylic acid. Okay, so because it's acid catalyzed, so you're regenerating your acid that you started with. So the acid is a catalyst. If it's base catalyzed, you go through the same mechanism, but the starting point is going to be different. Okay, so in base catalyzed, your HO minus is going to be directly attacking your carbonyl, your nitrile carbon, right? Okay, so under basic condition, this carbon will be attacked by your HO minus, right? You can think about that. Yes.
So on the step where the water is bonded to the carbon, is there any way for the water to leave the group and then the nitrogen to get its hydrogen from the OH?
Say it again. What's that?
The one where the water is bonded. No, the previous one. That one. No, yeah, that one.
Okay. What's the question?
So is it possible then for the water to leave and for the nitrogen to get its hydrogen from the OH group?
Now, so if the water leaves here now, right, it's going to be neutral, right? So there's no way base is strong enough to pick up that proton there. Okay, so that's why you need that acid to first protonate that for the water to come in. Okay, so yeah. Another alternative is way up there, but mechanism. It's very interesting though. If you guys can just, take your time to try to understand it, right? Now, think about it this way. When you get your amide, so let me cover this so that it's not messy. Let me cover that. Okay, let's come back to this step right there. Okay, I'm covering every other so that it's not looking too messy. At this point, when you have your amide, and you're trying to add your acid, okay, you can, because the oxygen is more electronegative, it will be protonated, right? But you could also have small amounts, so that you have an equilibrium that is shifted towards this intermediate more. But you could have small amounts of the nitrogen being protonated instead of the oxygen, correct? And if you have that, if you want to use this intermediate, the water can act as a nucleophile at this point. NH3 plus. Okay, and when you reform this carbonyl, okay, so let's see. So this can now pick up this proton. Correct? And if you form your carbonyl with any of these oxygen, let's choose this one here, you can essentially kick this out and form your protonated carboxylic acid, right? So you can go either way. Okay, so what we showed up there is going through this intermediate because it's more in the equilibrium, but you can go through these others. You're going to come to the same product. All right. This is where the video comes into play, right? So you can watch this again and all right. So let's move on. Hydrolysis. That was hydrolysis. You can also form. You can also react the nitrile with lithium aluminum hydride, and that will give you amines. So when you reduce your nitrile with lithium aluminum hydride, so that's the reducing agent. Okay, you'll form your primary amine. So this is primary amine. The mechanism, I think, you can try to look at that and try to understand that. That's very easy. So that will give you primary amine. Nitriles can also react with organometallic reagents like your Grignard reagents, because the nitrile carbon is electrophilic. So your Grignard reagent is going to act as the nucleophile, and you get an imine anion which is hydrolyzed to ketone. So alkylation of nitrile will always give you a ketone. So there'll be an intermediate here. I don't know if your homework platform is going to ask you to draw the intermediate. So whatever that alkyl group comes here on the Grignard, so that's the intermediate. Okay, which is the reason you need the second reagent. You can either use water or acid. All right. So with that, we've come to the end of chapter 20. Any question? Any question? No? Okay. No question? Okay. All right. Then we are going to start chapter 21. You're still on 19? We're already on 21. Do you guys have any questions? So let's basically recap. Let's recap what we did here, right? Okay. Chapter 20, what did we talk about in chapter 20? aldehydes and ketones, right? So the first thing we did in that is naming. You have to know how to name it, right? In aldehydes, you have to start with.
That's 19. That's 19.
What?
Aldehydes and ketones are chapter 19.
Oh, I'm already thinking about the quizzes I get, or the exam. Oh, okay. Oh, we are on chapter 20. We're going to 21.
Yes.
Okay.
We can start at chapter 18 again.
I know.
Practice. Go over chapter 18 and 19 a little.
All right, let's start 21. Let's do 21. Okay. Let's try to practice some questions.
Yes.
Anybody with a textbook?
Yes.
Okay, so let's just review what you're going to have in your quiz. We're going to solve more problems in the rest station, but let's start the solving of problems
The exam.
now. Yeah, we have an exam on Friday. Did I say quiz? Well, it's like a quiz because the questions are very few compared to what I used to put. No, you don't agree with that? Yeah? How do you determine it?
The net worth towards your grade.
Oh, okay. All right, so it's an exam, not a quiz. Okay.
It could be a one question.
Yeah. All right. Okay. Well, yeah. We were having that discussion with one of my colleagues. When to call it quiz, when to call it test, when to call it exam. So to him, a quiz sounds like, okay, if it's a quiz, I feel like it's a one question kind of thing, right?
Yeah, usually it's shorter.
Yeah.
More or less.
Yeah.
So that's from that angle. I'm looking at my exams now as good quizzes. All right, let's solve some problems.
Yeah.
What chapter? 18 or 19?
So since we have chapter 18 and 19 going into the exams, let's start with 19.
19?
Let's start with 19. Yeah, we've done a little of 18, so let's do 19.
Okay.
Huh?
You said 18 and 19.
18 and 19,
I thought I
yeah.
heard you say 18 and 19.
Well, I can put that too. You want me to?
No, thank you.
All right, so let's do something on
This problem right here, 1934B.
How do you take this out? There you go. You have a question there too, right? Okay. Oh, wow. Mechanism. People are getting. All right. By the way, I've not said the questions yet, so maybe you guys will be giving me a hint on what goes in there. So we'll see. Predict the product and provide the mechanism for each of the reactions below. So which one do you want us to do?
B, please.
B?
Oh, A. A is good. A is good.
Well, they're the same, right? The nitrogen. So the mechanism is going to be the same.
Yeah.
All right. So when you see a question like this, what should first come to your mind? What is this? An aldehyde or a ketone, right? Ketone, aldehyde. It doesn't matter. This is an aldehyde. That's a ketone. They react the same way. This is classified as what? Amine. So when you react an aldehyde with an amine, what reaction are you essentially conducting?
Enamine or enamine?
Exactly. So you are doing amination reaction, adding the amine to the aldehyde or the ketone. So the product you form will depend on the type of amine you're using. Okay. So the first thing you want to look at is what type of amine am I using? If it's primary, like in this case, you know that you're forming what? Imine. Yeah. But if it's secondary, like in this case, you're forming what? Enamine. Simple. So that's where you have to start from. Okay. So knowing that now, let's see. I can solve it on the back of this. So we can do C and D, right? So for C, I'm gonna draw the so that's basically how to analyze, the question before you start solving. You have to start from somewhere, and usually it's the analysis of what you're given. Okay, so this is a primary amine. So with an aldehyde or ketone, it will be forming amine. Okay? So basically, that nitrogen is replacing the oxygen, and the two hydrogen you have on the nitrogen is bonded with the oxygen to form water. We don't care about water, so you don't have to write the water. If you want, you can. So that's your product. Now the mechanism. Okay? So we know that aldehydes and ketone undergo magnesium. Again, when you answer this kind of question, you first have to draw your product because you get credit for that, and then you do the mechanism. Okay? So 1, 2, 3, 4. I'm going to draw the carbonyl here. So when you treat that, sorry?
It's supposed to be an aldehyde or a ketone?
It's an aldehyde. So this is an aldehyde.
Is the H
Hydrogen
going
is
up?
not singing.
Yeah, because it's skeletal structure, I usually don't show the hydrogens. Right? Okay, so this is going to act as your nucleophile, the nitrogen, attacking your electrophilic carbon of the carbonyl. This is too close to the amine I wrote there. That's too messy. I don't like that. So now this is positively charged. Okay? There will be a proton transfer. Okay, so now you have base, double CH3. Okay. Now this is where your acid or your base comes into play. So if you're using an acid, your oxygen in the alcohol is going to pick up that acid. So now you have base plus, you have the nitrogen, you have the hydrogen, you have the methyl group that you have on it. Okay? So the lone pair of electrons you have on the nitrogen now is going to be used to make a double bond with that carbon, kicking out water as a living group. And this is now positively charged. And the water you liberated will act as a base to pick up this proton and generate your neutral imine. That's the mechanism. All right. So let's do another one. And let's do another question. So you can use the same mechanism for everything that you have here. Okay. All right. So another question, one more question, and then we can continue in the recitation. Do you have a question there? Haha, I like this one.
You have to pull the two buttons on the bottom. Just push it down.
Yeah, I tried to push it, it wasn't. I didn't push it strong enough. I tried it, it wasn't. I need some muffins. Alright, I like this question here. 1935. Well, they're the same, but look at A for example. So what do you guys think of that? What do you think you form?
Which one?
A, 1935 A. What do you guys think it will form? What do you guys think? Okay, so do you recognize that product as an intermediate in any of these steps here? It's just a reverse reaction. Okay, so they give you an imine. Okay, they want to treat the imine with an acid and water. So basically, it's a reverse reaction. You're going back, you're hydrolyzing that to get back what you started with. So that's why mechanism is very important. So for A that you have over here, 1935A.
Protection. Making a ketone.
Exactly. So what you get is the ketone that you started with plus the amine. And what's the amine here?
The same as the C.
It's just the mechanism, it's just the reverse of the mechanism we just showed. Okay? So you can think about the mechanism. We'll do the mechanism in the rest station.
The HCl, what?
Yeah, so the HCl is acting as a catalyst.
Okay, so.
Hold on one second, guys. So the HCl is acting as a catalyst. Basically, the nitrogen is going to pick up that proton and become protonated. That is going to make that carbon to be very electrophilic, and water can add and go from there.
West Station, right?
We will. Alright. Oh, by the way, for those of you that came in late, I was able to make a link.